Chapter 3, Section 5. In this section, we're going to learn how to graph functions using vertical and horizontal shifts, and how to graph functions using compressions and stretches, and how to graph function using reflection about x-axis and the y-axis. So this section is the most difficult section in Chapter 3. Okay, because most students will feel very difficult to mastering the graphing techniques, which is the transformation. Okay, it just feels so much confusing and I don't know what to do. So I would like to quickly review for the functions we learned in the library, from the last section, and then I'm gonna summarize the transformation techniques. Okay, and then we go over some examples. So what we learned from last section, we learned 8 key functions in our library, right? So what you need to know about those key functions, you need to know the basics graph and the property of the function, okay, briefly. So we have learned 8 key functions. First one is called a square function. That's the standard form of square function. Okay, so what's the graph look like for square function? It's a parabola with vertex right at the origin 0, 0. Okay, that's the graph for square function. And then you can memorize the next function together with square function, which is called a square root function. Okay, square root function is half of the parabola, but parabola rotates to the right-hand side 90 degrees. Okay, it's this way. Okay, this is a graph for square root function. So try to memorize these two functions together because they have some similarities. And the number 3 we learned from 3.4 is called a cube function. Okay, f of x equals x to the third power, cube function. So what's the graph look like for the cube function? It's on the first and the third quadrant, okay, and the curve is towards the y-axis. This is a graph for the cube function. And then another function very similar, okay, is the third root function. Okay, so try to memorize cube function and third root function together because they have all the same property except the shape of the graph a little bit different. Okay, the third root function, the curve is more towards to the x-axis. Okay, if you can tell the difference between the two. So remember the third and the fourth together because they are highly related. And then the fifth function we learned is called the absolute value function. Okay, the standard form write as f of x equals absolute value of x. So what's the absolute value function's graph look like? It's a V-shaped. Okay, and this both side goes to infinity. And memorize absolute value function with the identity function together because half of the absolute value function actually is the identity function. I'm sorry. So identity function goes like that. So identity function, this part, okay, on the third quadrant, if flip, okay, do the mirror image about x-axis, and then that goes to the absolute value function, right? This part. Okay, so that's why they have a similarity. So if you memorize absolute value function and identity function together, and then that will be easier. Okay, identity function standard form write as f of x equals x. And then the number 7th key function in the library, that's the function we learned before. It's called a constant function, right? F of x equals b, where b is the intercept. And the last function is called a reciprocal function. Standard form f of x equals 1 over x. Reciprocal function has two parts, first quadrant, third quadrant. All right, so that's the A key function we learned from last section. And today we're going to use those key functions in the library and then use the transformation method, and then basically you can graph, any those derived function, okay, related to those key function in the library. All right, so that's the quickly review, okay, because we're going to use those key functions in this section. And then now I'm going to summarize, okay, what are the transformation techniques.